Hello and welcome to Freaky Physics. Today we're going to talk about electric cells and batteries, specifically about primary and secondary cells. First, let's look at a few terms. Resistance is the ratio of the potential difference across a conducting material and the current passing through it, as seen in this formula. Electrical current is the amount of charge flowing through a region per unit time. The potential difference is the amount of energy lost by a unit charge as it passes through a region. The electromotive force, or EMF, is the amount of electrical energy a unit charge gains due to an external energy source. Here are new terms for this unit. A cell is a single unit of an electrical energy source. A battery is a collection of cells connected to each other. A primary cell is a cell that acts as a source only. Primary cells cannot be recharged. Secondary cells are cells that can act as a source or a load on a circuit. Secondary cells can be recharged. The inner workings of cells and batteries are discussed further in chemistry. In physics, we are more concerned about the electrical properties of cells and batteries. Quick question: which ones of these things are cells and which ones are batteries? We will mark the cells with ticks. Here are our cells. And we will mark the batteries with stars right here. So what is the difference between a cell and a battery? Let's take a look at it in terms of biology. Cells are the basic units of life. Tissues, organs, and organisms are all composed of cells. Similarly, in physics, an electrical cell is the basic unit of electrical power. Electrical batteries are composed of electrical cells. Let's take a look inside some batteries. Here's a 9-volt battery and a car battery. You can see that in the 9-volt and car batteries, there are smaller subunits, and each of these is actually one cell. The difference between secondary and primary cells, again, is that primary cells cannot be charged. So which of these cells are secondary cells? Let's mark the primary cells with ticks and the secondary cells with stars. It's actually difficult to determine just from the look which ones are primary and which ones are secondary cells and batteries. Both primary and secondary cells discharge when used. In this simple circuit, with a single resistor and a single cell, the cell has an EMF E and the resistor has a resistance R. According to Kirchhoff's loop rule, a current I will now flow clockwise through the circuit like so. And Ohm's law now dictates that the current is equal to the EMF over the resistance. Since energy is used to make the current flow, the cell eventually discharges. Now let's look at charging secondary cells. We're going to attach a charger onto the cell like so. The charger has a potential difference V, and let's assume that the charger has a resistance. We will be focusing on the charger cell loop. According to Kirchhoff's loop rule, if the EMF is larger than the potential difference in the charger, then a current flows clockwise, and in this case, the cell is discharged. The idea is going to be the same for a reverse charger. However, if the potential difference of the charger is larger than the EMF, then the current flows counterclockwise in this case. This charges the cell. This is how phone chargers work, by the way, because the EMF of the battery is normally between 3.0 and 4.2 volts, while the charger is set to be at a constant 4.2 volts. So let's summarize everything here. We have learned the definitions of cells, batteries, and primary and secondary cells, and we've also learned how to charge secondary cells. Today's video lesson objectives are investigating practical circuits for both primary and secondary cells, and identifying the direction of current flow required to recharge a cell. I hope you enjoyed and learned something from that video. Don't forget to comment, subscribe, and hit the notification bell. For more interactive content, visit www.freakyphysics.com.